Okay, we are ready to start on page 85 of the exercise book. And this one is about graphing linear equations. And in the first section, we are using ordered pairs. This is on page 85 of the exercise book. The table contains ordered pairs for the equation. What are the ordered pairs for the table? So they have given us an equation. We could always just substitute our answer choices into the equation, but I'm just going to solve it and then we'll know what the ordered pairs are. I'll have to do it twice, so let me bring it over. So the first time I'm looking for y, so I'll leave y in there. And I need the negative 2 times negative 4 minus 3. So y would equal 8 minus 3. Y would be 5. So negative 4 and 5. I could pick the answer right there because only one of my choices fits. But let me go ahead and do what I'm supposed to, in case you're ever in the situation where you can't do that. So in this one, we're going to make y negative 11, leave the x in, and then solve for x. So add 3 to both sides and cancel. So you get 8 equals 2x. Divide both sides by 2 to get x is 4. And so that will be this one. So negative 5 and 4, negative 11. I like answer A for this one. Sorry, meant to do that. Okay, number 2. Consider the following table of values for a linear equation. Which ordered pair could not be in a table of values for this relationship? So I think how best to approach this. There are lots of ways you could do it. Let me show you 2 different ones, and then you can choose the one you want. The first thing that I notice is that there's a pattern in this table that every x is multiplied by 2 to get the respective y. So if I find a point that does that as well, that would be the answer to what I'm looking for. So, well, not necessarily. Let me work it as an equation. Hang with me here. Let's get slope. So I'm going to say y equals, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that's going to be 2 over 1 or 2. So slope is 2. And then I can set up, I think I'll use point slope, and I won't have to worry about baby b. Actually, I know the y-intercept, so I can do baby b. So y equals mx plus b, and we know that the y-coordinate of the intercept is 0, so you can plug that in. And then m is 2, and then x plus b. So this is confirming what I thought, that y equals 2 times the x value. So if you plug these points in, you will be able to tell which one fits. So negative 4 equals 2 times negative 2. That is going to be negative 4. So that point would be on the table. 0 times 2 is 0. So if you use, that point is on the table. It's part of the table. So that one definitely is in there. Let's check this one. 1 times 2 is not 1. So no, this one's not on the table. 2 times 2 is 4. Yes, that's true. So yes, that's a point. And then 4 times 2 is 8. That is also a point. So this method would have worked just fine. We're looking for the one that is not on the table. So I think that C is the one that's not on the table. You can also plug in the equation. It's the same. But all the equation's doing right here is multiplying 2 times the x value. And that's the same thing as what I'm doing right here. So those are the same thing. Either way you do it, though, your answer will be C. All right, number 3. Consider the following graph of a linear equation, which ordered pair would not be in this graph of a line. For this one, I'm just going to graph the points and see which one does not fit. Get the scale. It looks like every box is worth 1 in all directions. So -1, -2, that's on the line. 0, -1 is on the line. 1, 0 is on the line. 2, 1 is on the line. 3, 4 is not on the line. So that's the one that is not on the line. I could do those all day. I like that one. Number 4, consider the equation of the line, which ordered pair would not be in the graph of this line. So if you want to use that approach that I used earlier, you can. To do that one, you would need a table of values, or you don't have to have, but it's easier to see. So let me show you how this works. We're going to put our x value here. This is actually pushing us toward chapter 6, where we will look at functions. So x and y's. We want to test -3 and -1, 5 and 0, 1/2 and 6. Now don't get excited about a fraction, it's just a number. And then 10 and 25. So we need to figure out what the math is in this situation. So it's saying 2 times the value of x. So we're going to say x times 2 plus 5. So -3 times 2 is -6 plus 5. That is -1. That checks out. 5 times 2 is 10 plus 5. That does not check out. 1/2 times 2 is 1 plus 5. That checks. That's 6. -7 times 2 is -14 plus 5. That checks. And then 10 times 2 is 20 plus 5. That checks. So which one of them does not check? Well, clearly that is this one, and that would be your answer. Now, let me show you the way they wanted us to do it. I'll just do one of them because I don't really want to have to go through all this. 2x plus 5. So we are going to substitute the -3, the -1, and here is the -3. So -1 equals -6 plus 5. -1 equals -1, and that checks out. So it's the same thing. I'm just shortcutting a little bit with the table. You can do it either way. It doesn't matter. But you can get your answer by figuring out which one fits and which one doesn't. Or I should say which ones fit and which one does not.